we're going to take a look at right triangle congruence theorems. Now, there's a few of these that work off of the other ones that we've had. You know, side, 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 angle, or angle, angle, side. So we're going to take a look at which triangle postulates go with which ones. So first thing I want you to do, though, in your little book is get this one down. I'll give you a few moments to get that taken care of. Okay, so what we've got going on here with this one. Now, this is all given that we have a right triangle. So if I have a right triangle and I am given the angle A, angle D, and this side in here, we say that by the leg and the angle of a right triangle, these are going to be congruent. So if I look at this, and I see what it is that I have. So we know that angle H is going to be congruent to angle L. Okay? We've got that to begin with. Given. Then we have angle G is congruent to angle K. Again, these were given. Lastly, we have got LK is congruent to HG. Again, that was given. So we can say that triangle GHJ is congruent to triangle KLM by angle, side, angle. And since we have this as a right angle, and if we're given another side and another angle, or an angle between that, one of the legs, we've got it. So that would be all the information that we ever would need to know. Got a right triangle, I know what the angle is, I know what one of the legs are, I know that they're going to be congruent. So, I'm going to give you a little bit of time and I want you to get this one taken. Alrighty. So this one is supposedly hypotenuse angle. Now, please remember that in a right triangle, we do make a distinction between the hypotenuse as a side and the other two legs. Please keep that in mind. So, let's take a look at this. Should these two be congruent given the following information? Well, let's see. We have angle N is supposed to be congruent to angle Q. Both right angles, so that's given. We have angle P as being congruent to angle M. That's given to us. We are given that we have side MO is congruent to side PR. Again, that's given to us. So, what order of things do I have here? I have triangle MNO is congruent to triangle PQR. Why? Because I have angle, angle, side, angle, side. So, by angle, angle, side, we know that these two triangles would be congruent. Therefore, if we have a right triangle and we are given a hypotenuse and one of the angles, we know that the triangles are congruent. HL or HA triangle congruence there. So, here's the next one. Get this information down, we'll go through this one. All right, this one. This one goes through and identifies that if we have two legs that are congruent. Now again, remember, hypotenuse and legs, two different things. So, let's take a look at that. We have here, again, we've got our right angles, so we know that angle J is going to be congruent to angle R. We are told that, this is given of course, And then we are told that LJ, I got to get my angles and my L's to look better, don't I? It is congruent to TR given. We have side or leg KJ is congruent to SR. Again, that's given. So we have triangle JKL is going to be congruent to triangle RST by what? Well, we have a side, angle, side. Side, angle, side is one of the things that we have for proving a triangle is going to be congruent. So if I have two right triangles and the legs are congruent, I know that I am going to have congruent triangles. So here you go. One more for you to do. All right. Now this one here is hypotenuse leg. In order to prove this one, you'll notice that if I look at the order, I get the infamous side-side angle going on, right? The one we're not supposed to write down, right? Angle, side, side, bad idea. Angle, side, side, bad idea. Okay? Yeah, it'll take you if you see it written down on paper or you'll get the idea, bad idea. It doesn't work. So we're going to go through a different way of looking at this. If we have it as a right triangle, there is a way that I can go through and state that, yes, this is going to be congruent. So here we go. Now we are given that, let's see, and I do need to make this notation that angle U is going to be angle U, angle Y are right angles. That was given to us. We were told that WV is going to be congruent to XZ, given again. We were told that UV is congruent to YZ. Again, that was given to us. Now, I have to use the idea that those angles are right angles because what I am going to do next, and I'm going to kind of abbreviate this so not all the steps are there, but we are going to be able to see this. Because these are right triangles, would this work? WV, wrong one again. WU, if I could write a U, that would really be helpful. WU squared is going to be equal to WV squared minus UV squared. I'm going to be using the Pythagorean theorem here for this. Remember, if I were to go and set this as A, this would be B, and that would be C. So A squared plus B squared is equal to C squared, correct? Yes? This would be A, this would be B, and that would be C. So, like I said, I simplified things a little bit. I took the hypotenuse, subtracted one of the legs, compressed this a little bit. So by the Pythagorean theorem, I am also going to say then that XZ squared is going to be equal, oops, wrong one, XY, not ZY. That's right yet. XY is going to be equal to XZ squared minus YZ squared. Again, that's Pythagorean theorem. Okay, A squared plus B squared is equal to C squared. Now my question for you is, are these two sides the same? YV and YZ? Yes. Are u, v, and yz the same? Yes. So, could I get down to, after a little substitution, congruent to xy, but I use a little substitution and simplification, could I get down to that? If these are equal, those are equal, these are going to be equal, correct? Okay. So what I am going to do is I am going to say that triangle UVW is congruent to triangle YCX by side, side, side. So, like I said, I condensed this down a little bit, but you've got the understanding of it. A squared plus B squared is equal to C squared, correct? In a right triangle, and I know that I have a right triangles here. I have these two sides congruent by the Pythagorean theorem. We know what xy is going to be and uw, so they are congruent as well. So, next little thing here. Now it says Rachel must design a plastic cover to fit exactly over the metal plate shown. The cover will contain a right angle. Rachel knows that she only needs to pick two other dimensions to make sure that the cover is congruent to the plate. So what are all the possibilities? Now, this is where knowing these things makes life easier. I only need to know two measurements. So if I knew what PR was, could I also get by knowing what QR is and have enough information to say that they're congruent? Well, PR is the hypotenuse and this is the leg, right? We just got done using hypotenuse leg here to tell me that two triangles are congruent. So if I know that the hypotenuse and that leg are congruent, I've got it. Could I also say PR and PQ? Is that a hypotenuse and a leg again? Yes or no? What other one can I get by with? There's another pair that I could use. If I back up here, I've got, let's see, both legs, correct? If I know that both legs are, I've got a right triangle. So if I go down here and I take a look at this one, if I know what PQ is and what RQ is, do I have enough there to say that the triangles are the same? Most definitely. What else do I know? Well, here we've got, back up a little bit more, whoops, too far. We've got hypotenuse and an angle. So, if I take the hypotenuse, which we said was PR, and I know what angle P is, it'll work. Likewise, if I know what PR is and angle R, it'll work. So I would only have to go through and identify those. Lastly, if I go all the way back here to the beginning, if I know an angle and a leg, and the leg has to be between the angle, okay? I can't know that angle and that leg, that doesn't quite work that way. So, if I were to go and identify what, oh, let's see, angle, whoops, that isn't working. Angle P and PQ, I said PQ, and angle R and RQ. So if I knew those things, would I be able to go through and identify? And the answer is yes. So any one of those, if I just had those dimensions, I would be able to come up with the correct piece to fit over the top. So, now what I want you to do So I'm going to give you a minute or so here, and I want you to go and figure out why these triangles are congruent. Which one of our four original, angle, side, angle, side, angle, side, angle, angle, side, and side, side, side. Which one of these justifies this particular theorem? All right, so start off your test. Do you have a thought as to which one of the congruence theorems this one would be? To what? What am I supposed to hold on to? I think Parker's got the answer. Well, it says LA right there, Parker. Which one of the other ones goes to it? That's what I was asking Tessa. So what you got, Tessa? Now, side, 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 angle, side, angle. Angle, side, angle, she says. Angle, side, angle. Let's check this out. We know that the right angle is there. We know that AB here is supposed to be congruent to DE here, and that angle A goes with angle D. So, if we didn't have this information about the right triangles, these triangles would be congruent by angle, side, angle, which means that if I have a leg and an angle, I've got it. Leg, angle, these are congruent. So, I'm going to give you another minute or so here and think about this one. Okay, Parker, we're going for redemption here. What one do you believe that this one goes with? Well, don't you have this written down? No. Which one of the congruence theorems? Well, remember that was all this. We had these given to us a long time ago. Went through and put these into your little book. I'll show you again where they are in the stuff that I've got online for you. But AC is congruent to DF. Okay, angle A is congruent to angle D. So, which one of the congruence theorems does this one work with? So, if I look at this, in order would be angle, angle, side, angle, angle, side. So, angle, angle, side. That is the congruence theorem that we would normally use for the triangles. Okay? And since we got a right triangle there, HA congruence is going to work for us. So, look at the next one. So, Leah, which one of the triangle congruence theorems justifies this situation? Well, give me a guess. I mean, you should have worked this out already, but yes, I know you were thinking. Well, let's see. AB. One of the things you should always do is draw the triangles out so that you can put the congruence in. So AB is here, DE is over here, BC is here, EF is over here. So if I look at this in order, this would be side, angle, side, side, angle, side. So this one goes with side, angle, side. I know you were thinking that. It was just, you didn't have it written down, right? Gotcha. So, because these triangles are congruent by side, angle, side, and because these triangles are right triangles, if we know the measures of two legs, we know that these triangles are congruent. So, here's the next one to ponder upon. All right. So, let's see. Jacob, you got a thought? Which one this would be? Well, let's see. We said that AC is congruent to DF, correct? We've got BC congruent to EF. Now, if I take these in order, I get side-side angle. Side-side angle, or if we go in the reverse direction, we get the thing we're not supposed to have. So whenever you run across that situation, side-side angle, it's not something we can use. But in this case, we know that we have a right triangle. If I know two sides of a right triangle, do I know the third side? Yes, by Pythagorean theorem. So this one works by side, side, side. So side, side, side allows us to go through and say that HL congruence works. I know the hypotenuse and I know a leg. I know that it's going to be congruent. Yes, ma'am. But that's the same. See, when we go through and do these, the order has to be the same. So side, angle, side. Side, angle, side. Doesn't matter. It worked. So if I take a look at this one, this is side, angle, angle, or angle, angle, side. Either way, it would work. But because we tend to put things in alphabetic order as much as we can, we go at angle, angle, side. But if I went and identified this as side, angle, angle, I can reverse it and I get the exact same thing. Okay? It doesn't matter whether you go clockwise or counterclockwise. When you do it in the order, you must make sure that everything fits. So if I look at this one, angle, side, angle, or angle, side, angle, it doesn't matter if it goes forward or backwards. It still is true. Okay? So, I'm going to give you the last one here, and then I want to let you ponder on that one and see what you come up with. So, we have been told by Rachel that PR over here is 14 by 2, or 14.2, and QR is 8.9. Is this sufficient to make sure that all of the covers that were made will fit this metal plate? Is this true? Why? Which one of the right triangle congruence theorems is this going to work with? Well, what information were you given? You had two sides. Which two sides? You got to remember, a right triangle has two different kinds of sides. It has legs and hypotenuse. Yeah, so by HL, hypotenuse leg theorem, it's going to be congruent. So I'm going to let you guys get to work.